Hello, my name is Jack Van Zrugsch, and this is my video assignment for ME 210. So here's the video. As you can see, there's a hamster in the ball right here. It's our hamster. Um, but we're going to be figuring out the weight of this hamster based on the static friction coefficient and also the weight of the ball as well as diameter. Alright, I've turned the video into a problem. Basically, we got a hollow ball with a diameter of 15 centimeters and a weight of 0.9 kilograms, and it starts accelerating to the right there. And the hamster, in order for the hamster to move the ball, it's gotta be right here, which is around 30 degrees from the bottom. And we're here to look for what's the minimum weight of the hamster that's needed to move the ball when he's right here. Alright, so we're going to start with the givens and assumes, and we're also going to draw a diagram later. But first, let's start with the givens. We're going to start out with 0.075 meters, because 1 meter is equivalent to 100 centimeters, and we're going to obviously split that diameter in half to get that radius. And I presumed that the static friction coefficient is going to be 0.5. The mass of the ball is going to be 0.9 kilograms. And as I said before, the theta, the angle is going to be 30 degrees. And this is a hollow sphere, but it's kind of unnecessary. As for the assumes, we're going to assume that it starts at 0 because it doesn't move beforehand, and only when like the hamster applies the specific force at a specific angle it starts moving. And we're gonna obviously assume there's gravity that the hamster utilizes to move the ball. So our diagram's right here. The friction force will counteract this thing from rotating, and obviously it is the hamster, not the best. There you go, that's better. And the gravity of the hamster and the friction force fighting it. And here's the diagram. We got mass plus whatever the hamster's weight will be, and it's moving to the right. So we're gonna figure out the force of friction that's applied. We obviously have the ball, which is going to be 0.9 kilograms, the mass of the gravity, and the constant static force friction coefficient, which gets us this. And this isn't exactly this. I don't know how I did this, but we can cross that out. And we're gonna find the FG, which the hamster has to push the ball. We're gonna use cos 30 because we're looking for this angle. We don't know what this is, but we're gonna use this to get this equivalent to this, which will get us that. And we get that through our calculator. And since we're looking for the mass and not the weight, we're gonna have to divide it by gravity, and we get this. Yeah, that's about it. Thank you for watching.